Hi, I'm Dr. Fox, and let's talk about the accessory organs of the oral cavity. In this video, we'll discuss the accessory organs of digestion, where they're found, what they may secrete, and how they aid digestion. We'll outline the oral cavity and the accessory organs of the oral cavity, describe the role of saliva in digestion, describe the location, ducts, functions, and innervations of the major salivary glands, and discuss the role of the tongue and teeth as accessory organs in digestion. So what is an accessory organ for the digestive system? It is anything that aids in either physical or chemical digestion without being part of the gut tube itself. And so there are two regions where accessory organs sort of congregate their function. The first, and that will be the large focus of this video, is the oral cavity, where we have the teeth, the tongue, and the major salivary glands. And the next is in the midgut, where we have secretions from the liver and the pancreas that are secreted into that second part of the duodenum, where they chemically help to break down chyme into more digestible and absorbable materials in the midgut and regions distal. So let's turn our focus to the oral cavity. The oral cavity is everything that is deep to the oral fissure and anterior to the oropharynx. Recall that is the palatoglossal fold that prescribes that division. The oral cavity is divided into the oral vestibule, oral cavity proper, and the sublingual space. The oral vestibule is everything that is superficial to the dental arcades, or the teeth and the gingiva, or gums. It's into that space that the parotid gland, which is one of three major salivary glands, secrete. We also have the teeth as accessory organs in that they help to tear, pierce, shred, and grind food. And within the oral cavity proper, we have secretions from the submandibular gland that exit at the caruncle and the sublingual glands on either side, which exit into that oral cavity proper. We also have the tongue, which is elevated to the roof of this individual's mouth, that helps with handling food, sensing food, and moving food posteriorly into the pharynx. So there are major salivary glands and minor salivary glands, which all secrete a substance known as saliva, or colloquially spit. What is saliva? Well, it's mostly water. It also contains quite a bit of mucus that's basically secreted water with proteins and lipids in it, as well as digestive enzymes and other materials. Saliva functions to moisten and lubricate mucosa. It also serves to moisten and lubricate bites of food that become boluses to aid in the deglutition response, or swallowing. Saliva also begins the process of digestion. So within saliva are amylases and rudimentary lipases, which break down starches and lipids on their way to the stomach. Saliva is secreted by salivary glands, the three major of which are the submandibular, which secretes 65% of saliva. The submandibular glands are found in the submandibular triangle of the neck. Then there's the parotid glands, which secrete about 20% of saliva. The parotid glands are found sort of anterior to where your ear is, intermediate to the ramus of the mandible. And then the sublingual glands, which are found in the sublingual space, just deep to the tongue. Let's take a look at the parotid glands. So here we have a lateral view of a cadaveric photo of an individual donor, and I'll outline the parotid gland there. It's just anterior to the auricle of the ear, and it's laying upon the ramus of the mandible. We can see that parotid gland has a duct known as the parotid duct or Stenson's duct that exits from the anterior aspect of the gland and goes deep into the buccal space, where it will pierce a muscle known as the buccinator, and it secretes into the oral vestibule through a papilla that is adjacent to the maxillary second molars. So it is posterior in that oral vestibule against the molars, where parotid salivation occurs. The parotid gland is served by the glossopharyngeal nerve. So the preganglionic parasympathetic fibers come from cranial nerve 9. Teeth are also accessory organs of digestion, so working from the oral vestibule into the dental arcade. These are structures that cut, tear, pierce, and grind food. We divide up the teeth into different quadrants. So there are 2 quadrants on the maxilla, 2 on the mandible, and each quadrant will have 8 teeth. So you can up to a total of 32 teeth on average, 2 of which are incisors, which help to cut food. 1 within that quadrant is a canine, which helps to pierce food or tear food. 2 are premolars, which are good at tearing and grinding food, and 3 are molars, which are very good at grinding food. Those third molars are sometimes known as wisdom teeth because they tend to erupt the latest, usually around the ages of 18 to 22 years of age. What that has to do with wisdom, I don't know. The teeth are innervated by divisions of the trigeminal nerve, or cranial nerve 5. So the maxillary teeth are innervated by the maxillary division of the trigeminal nerve, known as V2, whereas mandibular teeth are innervated by the mandibular division of the trigeminal nerve, which is known as V3. Beyond the dental arcade, we have secretions from both the submandibular and sublingual glands. The submandibular glands are found in the submandibular triangle. So as students dissect in the laboratory, these often appear to them as masses of epithelial tissue, glandular epithelium. They kind of superficially resemble walnuts in that space. They have ducts known as submandibular ducts, also known as Wharton ducts, that traverse the sublingual space and secrete at the sublingual caruncle. If you have ever gone through elementary or middle school, you might have heard of the phenomenon of gleeking. Gleeking is where you forcefully eject saliva from that sublingual caruncle. So you spit by forcing saliva from the submandibular gland out those holes. Some people can do this on demand. Most people cannot. And the preganglionic parasympathetic fibers that serve the submandibular glands come from the facial nerve, cranial nerve 8. The nerves that serve the submandibular glands, that provide the preganglionic parasympathetic fibers to the submandibular glands, are from the facial nerve, cranial nerve 7. Also served by the facial nerve, cranial nerve 7, are the sublingual glands. The sublingual glands get their name because they're found in the sublingual space. So here we can see a donor that has had their sublingual space opened, the tongue is reflected, the mucosa is incised, and we can see that submandibular duct there, and between that duct and the mandible, we can see the glandular epithelium of the sublingual glands. Now, if you were to look at your own oral cavity proper in a mirror, if you were to elevate your tongue, you would see these ridges or sublingual folds, and it's within those sublingual folds that the sublingual glands occur. And all along the length of these folds are the sublingual ducts. So both the submandibular and sublingual glands, preganglionic parasympathetics from 7, and they're secreting into the oral cavity proper. Now let's take a look at the tongue. The tongue is an organ that is great for handling food. It helps to mix bites of food with saliva to begin that process of mechanical and chemical digestion. It helps to form that bolus of food prior to swallowing or deglutition. It's also covered by a bunch of papillae, specifically lingual papillae. So there are several different types of lingual papillae. There are filiform papillae. Filiform papillae are purely tactile. They're found all over the body of the tongue, and they are what allow you to detect texture of food particles. Does it feel smooth? Does it feel rough? Can you get a good sense of proprioception in molding boluses? That's complements of V3, the mandibular division of the trigeminal nerve. There are also fungiform papillae. Fungiform, fungi, they look like little mushrooms under a microscope. And these are going to be special sensory, specifically for gustation or taste. Of the anterior tongue, where these fungiform papillae exist, these taste buds are innervated by cranial nerve 7, or the facial nerve. We also have foliate papillae. Foliate papillae are more on the lateral aspect of the tongue, and they tend to be more concentrated in younger individuals. We lose these as we age. Foliate papillae are also controlled by cranial nerve 7 as well. So special sensory for taste coming back through the facial nerve. Then we have valate papillae. Valate papillae are beyond the terminal sulcus, and we can see them here. Valate papillae are very distinct, very large, and they are special sensory for taste, but they're controlled by the glossopharyngeal nerve, cranial nerve 9. Now, the tongue itself is a muscular organ. The muscles within the tongue are the intrinsic tongue muscles. The muscles that connect the tongue to other aspects of the skull or the hyoid bone are extrinsic tongue muscles, and all but one of these muscles are innervated by the hypoglossal nerve, or cranial nerve 12. So the hypoglossal nerve is going to be the major nerve controlling the motion of the tongue. The only extrinsic muscle that is not controlled by the hypoglossal nerve is the palatoglossus muscle, which is controlled by the vagus nerve. So we've discussed accessory organs of digestion, specifically accessory organs of the oral cavity, the role of saliva in digestion, the locations, ducts, functions, and innervations of the major salivary glands, as well as the role of the tongue and teeth in digestion, as well as their innervation. Thank you so much for your time, and I'll talk to you soon.